Oh wow, I just decanted off the water layer. Now you can really see how nice these look. Dang, man. Oh, they're beautiful. Since I'm on a chemical purification via recrystallization kick, and I've been quite obsessed with crystals lately, well, my whole life actually, I have some of this stump remover, which is just potassium nitrate. I got this at Lowe's. It's like, I don't know, like $7 for this. What do we got? 1 pound. So there you go, $7 a pound. I'm going to use this to make some nitric acid. Once again, it doesn't really say what all is in this. I think if you peel this back, it does say it contains potassium nitrate, but it doesn't give you like a ratio of how much potassium nitrate's in it and how much of other crap is in it. So I'm going to do a small purification by recrystallization process with this, mainly because I really like the way potassium nitrate crystals look. And I figured that'd be an easy little video to do to show how I do recrystallization processes. I have my magnetic stirrer and stuff over there, but I'm actually not going to use it. I'm actually going to use this cheap little, I guess it's a hot plate. I don't know. I found it at my local Goodwill for like $4, and I kind of want to do this on this instead of my burner to show you don't even need, like a fancy magnetic stirrer hot plate. You don't even need to use beakers. The only reason I'm using a beaker is because I don't have like any Pyrex containers out here. But you could easily do this in a Pyrex measuring dish or even like a pot, like a saucepan or something. The first thing I'm doing, I'm just heating up 400 milliliters of tap water. This isn't really for the actual crystallization. The reason why I'm heating up the tap water is because once this reaches a boil, I'm going to pour that into this vacuum flask in order to kind of temper the temperature inside the flask, because once I have my potassium nitrate and water solution heated up and ready to start crystallizing out, I want the vessel which I'm going to be pouring the potassium nitrate water solution into to be warm. That way it doesn't start crashing out crystals immediately and forming really small impure crystals. One of the best ways to purify chemicals is to let them slowly crystallize out of solution. And the nice thing about potassium nitrate, and really a lot of these salts, is the solubility of them increases fairly dramatically with temperature, at least in water, and then decreases very dramatically as the temperature decreases. So you can dissolve a lot more in a boiling solution than you could in a freezing solution or a cold solution, which means we can take 400 milliliters of distilled water. Once this heats up, I'll pour that in here, put the cap on so that, like I said, this is nice and warm, and then I'm going to put 400 milliliters of distilled water in here. And then I'm going to pour some potassium nitrate into the distilled water, stir it until it no longer dissolves anymore potassium nitrate, and then I'll just put a little splash of distilled water in just to kind of up the water content so that everything dissolves. We'll have a super saturated solution, and then I can pour the hot potassium nitrate solution after I pour the hot water out of this into my vacuum flask here, and pour that in here, close the lid. And the nice thing about vacuum flasks, they have this metal interior and they have this metal wall on the outside, and in between those two is a small void, a vacuum, and that makes it very insulating, which means that this will cool down very slowly. And like I said, if you let a solution that has something in it that is very soluble in high temperatures, but very less soluble at lower temperatures, if you let that solution cool down very slowly, it'll crystallize out these really nice large crystals, and it's really easy to do. I'll show you how striking the actual results can be just for doing this simple procedure. I've seen other videos where people recrystallize like potassium nitrate by taking water, and then they'll pour the potassium nitrate in, pour it in, stir, and they'll just keep doing it until it's basically like almost a gelatinous blob of molten potassium nitrate mixed with a little bit of water. And then as soon as they start pouring that out, it'll actually start to... I've seen like videos where people are pouring it out and it just like crystallizes up, kind of like hot ice does. And that's not the way you want to try to purify things via crystallization, because the smaller the crystals, you're not like... The nice thing about crystals is they form from the actual material, like the atoms or the molecules themselves, sticking to each other and arranging themselves in like a crystalline structure, and that makes a very pure product. And the bigger the crystals are, the more pure product you will have in those large crystals, opposed to, you know, smaller crystals. It'll just be smaller chunks of the substance that you're looking to purify. And the smaller ones also have a tendency to trap impurities in between the crystals, just because there's more surface area for them to trap impurities between. So the larger the crystals you can get, the more pure and the better your end result will be. So once this reaches a boil, I'm going to pour this into here, and then we'll start with the actual potassium nitrate solution. So once this is ready, then I'll start the video back up. If we look up the solubility curve for potassium nitrate, here's 100 degrees Celsius, which is, boiling point of water. And it looks like, oh my gosh, we can dissolve 250 grams per 100 milliliters of water. That's quite a bit of potassium nitrate. I forgot how soluble that actually is. But if we look down here between 0 and 20, it's actually really, it decreases very much by the time we get down here. So I think I'll still stick with the, maybe I'll just go with 300 milliliters of water, and then do 500 grams of the potassium nitrate, because it'll actually be kind of good, because then we won't have a super saturated solution at, even at 100%, 100 degrees Celsius, it won't be a super saturated solution. But once it cools down, then we'll still have a lot of stuff crystallizing out. So yeah, we'll just go with 300 milliliters of water and 500 grams of potassium nitrate. I think that'll be a lot better. Change of plans, kinda. Okay, got the boiling water added to our vacuum flask. Put the beaker... I'd better wait until I put the water in here before I put that back on the heating hot pad, because I don't want to crack my beaker. I've done that 100 times now. I don't want to do it 101 times. Alright, let me get my distilled water. Like I said, I'm just going to measure out 300 milliliters of distilled water this time, instead of 400 like I originally had planned. Pour this into our beaker. Alright, so now that is on the heat. Since I made that last minute change of plans, I'm going to actually weigh out my potassium nitrate here. There we go. Now, the more I got to thinking about it too, the more I was getting scared that I wouldn't be able to hold the 400 milliliters of water along, like the vacuum flask I'm using can hold like 425 milliliters of water, I think. But the volume's obviously going to go up quite a bit because we're putting a lot of potassium nitrate into the solution. And look at this. See, that's why, let me zoom in here. Where'd it go? That is why it is best to purify any technical grade chemicals that you may encounter, because very often than not, they have a lot of junk and stuff that you don't really want in them. I mean, if we want to do this right, we'd filter that, there's a lot of ways to do this, but honestly, this is an okay process for me, for my purposes. You still could, like I said, just bring some water up to boil and then start adding potassium nitrate until no more will dissolve, and then add another splash of distilled water. and do that instead of having to like weigh anything out. But we'll just be a little more precise here. All right, so now it's just a matter of letting this heat up until it comes to a boil, and everything, here we go, everything should dissolve. Once everything's dissolved, I will restart the video. So I will see you then. Update in a change of plans to the change of plans. And also a word of advice. I recommend bringing your water up to temperature before pouring in all of your potassium nitrate because it tends to form these very thick, clumpy layers on the bottom that are really, really hard to scrape off, and they seem to be really insulating, which makes it a little more difficult to bring the water up to temperature, at least, quickly. But I got to thinking about it, and even though we didn't do anywhere close to a saturated solution at boiling point of 100 degrees Celsius, I'm still afraid that once this cools down, you see how there's a layer of the potassium nitrate on the bottom there because it hasn't all dissolved in yet, because this isn't boiling yet. I'm afraid that even though we haven't made a saturated solution, once this does crystallize out, that we're going to end up with a big layer of like just kind of ugly crystals on the bottom. And it won't even be like crystals, it'll just probably be like a big solid chunk of potassium nitrate. So one thing that I think I am going to do is I'm currently heating up 200 milliliters of additional water here in this little beaker. I am going to then, once this is a little warmer, I'm going to pour it into here, dilute this even further, and we'll still get some nice crystals developed once this cools down, because, like I said, the solubility of potassium nitrate decreases so dramatically with temperature. Now, obviously, once I add this into here, we won't be able to fit all of the potassium nitrate solution into the vacuum flask, which is fine, because that will actually give me a chance to film this in time-lapse so you can actually see things crystallizing out. And I kind of also want to compare what this will look like crystallizing out at room temperature, which is, it's actually going to be pretty cold out here tonight. I'm not going to really keep the heat turned on too high in my shop tonight because it's going to be really cold, and I don't want to use a lot of electricity, so it'll probably be about 45 degrees Fahrenheit in here. But like I was saying before I got off on that tangent, I kind of want to show not only a time-lapse video of this crystallizing out, but I kind of want to compare what just normal, like letting this cool down at room temperature crystallization looks like compared to letting this solution cool down in a vacuum flask. So that's the new plan. I think that's the plan we're going to stick with. I don't think I'll be making any more changes, so I haven't done this in a while with potassium nitrate, forgive me. It looks like all of the potassium nitrate is dissolved in the big beaker. It's actually kind of funny. It's so cold out here compared to, the potassium nitrate solution, that even though everything's dissolved down here at the bottom, it's starting to form these crystals on top. So maybe it is a good thing that I did that change of plan and boiled this 200 milliliters extra of water. I also am kind of glad that I boiled that, because I want to use this boiling water to wash the potassium nitrate that's collected on the sides of this beaker. And once I get that rinsed off, I will switch out this glass stir rod, because this just has a stalactite of potassium nitrate on it. And whenever I go to pour this in its final resting location to let it cool down, I don't want there to be any seed crystals if possible. So what I'm going to do is take this 3 milliliter dropper here, and I'll start taking my distilled water, and I'll just use that to wash off the sides of the beaker here. which it's actually working out really nicely, and it's going by really fast. I don't even really have to speed this up. I can just do this in real time, which is great. I might just be able... Yeah, I can just rinse off the potassium nitrate stalactite here, too. Alright. See some up here. I'm just going to try to rinse down the beaker as good as I can, especially here in the pour spout where the potassium nitrate solution is going to be coming through, like I said, just to try to avoid any seed crystals if I can. That way they only start developing once it starts cooling down past a certain point instead of pretty much immediately after it leaves the beaker, if that makes sense. Kind of like with candy making. You want to make sure that there's no crystals on the side to ruin your batch of hard candy. Alright. Looks good. Let me stir that in here. And now that we have that extra water added in, no more crystals forming on the surface. All of the water has been added. The solution of potassium nitrate looks really good. It's very cloudy, so there must be a lot of gunk and a lot of junk in that stump remover, but that's kind of to be expected. You know, they're not going to give a crap about purity for something that you're literally going to burn a stump with. So this water is not the original 250, well, the 200 milliliters that were in here. I just put some of this water from the vacuum flask in the bottom of this after I added it into here, so that, you know, this wasn't sitting on the burner dry, because I want this beaker to still be hot whenever I pour the potassium nitrate solution into this. Does that make sense? So I guess now I am going to get everything ready. I'm going to pour some potassium nitrate solution into this, pour it into this, and then I will set up my one camera for time-lapse and just kind of let this go overnight. So let's do that. I'll just I'll record myself while I do this, but I'll just probably speed it up and just put weird music to it so that I don't have to talk while I'm doing this, because I gotta kind of blow through this as fast as I can. And good. And one nice thing about pouring the water off into that vacuum flask and that other beaker is, look at all that crap. But like I said, this is something you literally use to burn stumps or have them decompose faster, so they're not going to really care about purity too much. Alright, let me set up for time-lapse for this. Let me make sure the cap for that is really tight. There we go. And just to be even more paranoid, I'm going to go over here into my messy work area, and I'm going to get this small styrofoam container that has blue stuff in the bottom, but that's fine. And I'm going to add one more layer of insulation so that hopefully this cools down even slower. And I'm going to put this into a styrofoam cooler. We'll come back tomorrow and see how everything looks. Like I said, I'll get this set up for time-lapse, so we'll see how they both look tomorrow, okay? See you then. Wow, these guys turned out great. Look at that. Very nice. I'm actually surprised they grew that well, just sitting out here at room temperature. I thought that maybe they'd kind of all solidify out on the bottom. But no, we got these really cool, like, needle-like structures growing from all kinds of different angles. What's it look like from... You can't really see... you can kind of see down in there. Alright, well, that's good. Now, let's see what... Let's see what these guys look like in the vacuum flask. because that's when this is the first time I'm seeing them. Here we go. Ooh. Oh, those are really, really nice, actually. Dang, dude. I know, they turned out awesome. Oh, wow, I just decanted off the water layer. Now you can really see how nice these look. Dang, man. Oh, they're beautiful. I love nitrate crystals. They always look so cool whenever you grow them like this. Oh, wow. I almost don't want to take them out of there. I just want to leave them in. Alright. I guess I'll dig them out. I'll just pour the water off of these guys, too. Yeah, these are really nice as well. These are bigger. These crystals are bigger, as you'd expect, because they cooled down a little bit slower. But these ones over here are really nice as well. Alrighty, let me get to it. I managed to get them out of the containers and break my 250 milliliter beaker while I was at it. I'm going to actually wash these really quick with some cold distilled water, just because there was a little bit of a particulate there that was in the original solution that kind of settled to the bottom. But it did stay in solution. It's just kind of stuck to the crystals. And it can easily be washed off with distilled water. And I shouldn't lose a whole lot of potassium nitrate in the washing step, just because the water in this is about 3 degrees Celsius. I just took a temperature reading, so it's pretty cold. We shouldn't lose a whole lot of our crystals, which is good. Looks pretty good. Nice. And I'll just do the same thing for the other beaker. I'm going to end this video here because I think you've seen all that you need to in order to do this yourself. A couple things I want to mention before I go. I have done this before. Like you saw, like you'll see in this. I haven't watched the time lapse, but you'll see in the time lapse how those crystals kind of grew just at room temperature, or even colder than room temperature. Because, like I said, it was about 45 out here last night in the shed. So we still got those nice large chunks of potassium nitrate crystalling out, even without it like slowly cooling down in a vacuum flask, which I then kind of OCD-ly put into my styrofoam cooler here. But if you want to try to get just a little bit bigger crystals, what I've done before is I will put them in, I'll get the saturated solution, or else the highly concentrated potassium nitrate solution, or any other kind of like salt solution that you're trying to crystallize out. Make sure that the top is covered. I use like a watch glass or some aluminum foil or something. Take that beaker, set it on top of a doubled over dish towel, and then drape over a couple dish towels on top of the beaker as well. That'll create like a little insulating environment for it as well. But now all that's left to do is I'm going to wash this other beaker full of crystals here. That way they're just a little more pure. And then I will put these on a styrofoam plate or something similar, and then I'll just let them dry. Once they're dry, it'll take a couple days, but once they're nice and dry, then I'll just put them in a clean container for long-term storage. And I'll have a relatively pure sample of potassium nitrate for any future reactions. I'm not going to use this for my nitric acid synthesis. I went and got another bottle of this stump remover so that I can just use the technical grade, like junk stump remover potassium nitrate for the nitric acid synthesis, because why would I want to destroy my nice crystal? I hope that this video was entertaining to you. I hope it was informative. I hope you enjoyed it, and I hope you learned something. Alright guys, give me a thumbs up if you like this video. Please comment, share, subscribe if you haven't subscribed already. I'll see you next time, guys. Take care. Bye-bye.